backside is the kind of problem I tried giving you guys outside, and you really weren't ready for it yet.
I was like,
So what's different about these compared, or at least the top two, compared to the ones we're doing outside in the front of the paper? Yeah?
There was something outside of the
Yeah.
absolute values, and it's on the other side of the equation.
Yeah.
Get some sanitizer.
So we have to remember to first isolate the absolute value. So these are different because the absolute value is not currently alone equaling a number. So you have to isolate the absolute value first before you do the rest of this. So in this case, I have to move this 5 over before I can set up my 2 equations. So if you notice on the front side of the paper, we had 2 steps to these problems. It was first set up the absolute value and then set up 2 equations. So we're going to move that 5 over first. So I have a negative 4x, absolute value equals 16. And now this is where the heart would come in. This is where we cover up what's underneath the absolute value and set up our 2 equations. So both positive 16 and negative 16. Set up our 2 equations there. And in order to get epsilon in this case, we're going to divide by negative 4, right? So negative 4 is one of our answers. But then this one will also be a positive 4. This is one of those unique cases where it's actually both the positive and negative version of that same number. So 5's a little bit trickier because it has more going on than just something being added or subtracted. What do we need to do in number 5? Okay, so I actually like that you said distribute. It's not correct, but I'm glad we're talking about it. We don't want to distribute with absolute value. Kind of going back to the front side here, we didn't want to distribute this negative 2 in. Same thing goes here. We don't want to distribute with absolute value. Yes? Yeah, so let's get this 5 away. Yeah, and then that 2 is being multiplied. So to get rid of it, we can divide by 2. So rather than distributing in, it just, sometimes it'll work to distribute and other times it won't. So we need to make sure that we kind of just don't do it for sake of safety of all problems. Because we want to make sure they're all safe. So we divide by 2, and we end up with 10. And now we can set up our 2 versions of this problem. So x plus 3 equals 10, but x plus 3 also equals a negative 10. So that's the big difference between what we were doing on the front side compared to what we're doing here, is we need to isolate that absolute value first. Questions there? All right. Why is number 6 special?
No solution.
Yeah, so this is the kind where you should almost be excited when you see it because you're like, not a whole lot of work to do there. Anytime the absolute value is by itself and it equals a negative number, it's not possible to think of anything that would go there. There's no way to take an absolute value and have it end up being negative. So this one's no solution, and seriously, that's all you have to do. You don't have to show me anything else with it. It's probably one of the only times I say 0 work is required there. Now this next one's kind of like a shouty problem. It's like yelling at you. Those are supposed to be absolute value symbols around there, so it's supposed to be like -2, absolute value 10, plus 2x. Now this one equals a negative. So does that mean it's no solution?
I thought it was no solution.
This one is. It was 6. Is this one no solution?
Yeah, that's negative.
No.
But it has the -2.
So this one's a little bit different. This one's an absolute value equaling a negative. What's the difference here?
-2.
There's a -2 in the front that causes this to change. Because if I want to get the absolute value alone, I have to get rid of this -2. So what am I going to do? What's -2 doing to the parentheses? Multiplying. So I'm going to divide by -2, just like we did up here. Divide by -2. This cancels. What now happens to what this equals? Becomes a +6. So now this one makes sense. This one's okay now because of the fact that it equals a positive. So now we're just going to do like we've done before. We're going to set up our 2 equations. So this one's kind of a special case. Just want to make sure we kind of point out some of those tougher ones. So both of these answers are going to be important. They both will work. We get a -2. And also a -8. All right, and then I just want to show you guys how this kind of works with word problems, and then we'll be done for today, unless you guys have time to work. So with word problems, absolute value does actually kind of make sense. And where I had to use this was when I had to take a computer programming class in college. And by the way, I'm a horrible computer programmer, so that did not go well for me. But the idea of the math behind it I really liked, because there is math behind computer programming, and so that part of it I like. So it says your speech in class needs to be 120 seconds long with an absolute deviation of 30 seconds. They use these words, it's kind of weird. So that means it means plus or minus 30 seconds. So if you go 30 seconds over, it's okay. 30 seconds under, it's okay. But you can't go more than that. So the biggest difference can be 30 seconds. So we want it, though, to be 120 seconds long. So I want it to be 120 seconds long, but it could be a difference of 30 seconds from that. So the absolute deviation, or they could say like how much you can go away from that, could be 30 seconds. Whoops, now that I think about that, I have it flipped. Dang it. Oh, it's telling us, sorry. Sorry, everyone. Sorry, everyone online. I have these flipped. And the reason I know I have them flipped is because I would get a negative answer. So I have this all mixed up. I apologize.
Whoa, teachers making mistakes.
I know.
Wow.
So stupid. Okay. Forgive me. Okay. So it goes the other way. The absolute deviation is 30. So that's the most it could be positive or negative. And again, the way I figured that out is the answer just wasn't making sense. There we go. So at most, it could be 150. At least, it could be 90. So if they use those words, absolute deviation, they're talking about the value on the other side of the absolute value. So that's what I got mixed up. you guys, and that we do tomorrow. So you guys have the rest of the time to get working. Again, kind of listen to the bell schedule as we are leaving here. Yep.
Can we look outside?
Probably not. I think I can't sorry. We were just outside. You'll be okay.
Yeah, especially with the walk home.
Squirrel keeper again. All right, so homework is listed there.